Well, hello boys and girls, how are you today? Yes, this is Mr. Brisson and I am in the classroom today. Somebody's probably about to come in, that's why I had the mask on, but I'll go ahead and take it off. And did I say that I was Mr. Brisson? I think I did. Anyways, here, I don't have to say my name, you already recognize my face. Here we are to do another science lesson, okay? Well, today's lesson, I missed a couple of things in the waves, in all the lessons that we did about the waves, and I want to make sure there are 4 things, okay? 4 things. Well, it's really 2, but each one is 2 things that I want us to understand clearly, okay? So our target today is I want to make sure that you understand what a transverse wave is, transverse, and what a longitudinal wave is. Okay? So I want to make sure that you understand those. All right? Before we get into transverse waves and longitudinal waves, there are 2 words that I want you to understand, okay? There are 2 words that I want you to understand. And maybe you know them from math, maybe you don't, okay? So, these 2 lines, those 2 lines, they never meet, okay? So they never meet, but goes at the same distance, always, and they never meet. Those are what kind of lines? You remember? Starts with a P. That's right. Parallel lines. Because they go in one direction and they never meet. And this type of line right here, they form a 90-degree angle. So those lines, do you remember what they are? It also starts with a P. Do you remember? They are perpendicular. They're perpendicular lines, okay? So here are parallel lines and perpendicular lines. Understanding this is extremely important to understanding the 2 types of waves, okay? I'm going to erase this. And then I want to first talk about longitudinal waves, okay? So longitudinal waves. And you can see the word long there, long, okay? So, in the past, we already talked in another lesson that sound waves are longitudinal, okay? So, the way that it works is, let's say that there is a drum here, right? And let's make the drum like this, okay? And we hit the drum, right? So, there is a disturbance in the air, because remember that sound needs a medium, in this case air, and the particles are disturbed, and these particles disturb the other particles, and those particles disturb the other particles until it gets to the ear, okay? So, the way that they would look, it would be something like this. And then longer over here, and then again straight over here, and then longer like that, okay? So, this right here is compressed, and this is rarefied. So, these particles are moving in this direction. The particles are being disturbed in that direction. And the sound, that sound energy is also moving in that direction. You see? So, because the energy and the particles are moving in the same direction, we call those in parallel, like parallel lines, we call those longitudinal waves. Okay? Now, let's go ahead and go to the transverse waves. The transverse waves. Remember the word perpendicular? Okay, so like for example, light waves are transverse, okay? The way that it works is, it looks something like this. Okay? And the particles are going up and down, up and down, up and down. But the energy is moving like this. So if we were going to draw a line from the particle down, or from this one, or from this one, or this one, or this one, you see that we have perpendicular lines. So when the particles go up and down, but the energy is moving that way, they are perpendicular to each other, and we call that a transverse wave, okay? So I know that I've done a lot of talking, but you really need to understand it. And what I'd like you to do is, in your notebooks, okay, you could draw the transverse waves, and then you can also draw like this the longitudinal wave, okay? Longitudinal. And you could do the lines like this, and you can do the lines like this, so that you know that this is longitudinal and this is transverse, okay? I need to make sure that you understand that. So boys and girls, I'm going to put my mask on for the second part because there is another teacher in the classroom. Mr. King is here, okay? So the other part that I want to make sure that you understood clearly, okay, was the three ways that light behaves on our planet, all right? So let's look over here to see how that happens. I'm going to go over the three words first, and then we will discuss each one individually, okay? So if we look over here, we see that the first word is absorption. The second one is refraction. And then we have reflection, okay? Those are the three words. So one more time, absorption, refraction, and reflection, okay? So those are the three that I want to discuss. We talked about a little bit in some lessons in the past, but I want to make sure that you really understand those. Here is a bulletin board, and I use black paper for the background, okay? So black is related to this word, absorption. And how is it related? You remember when we talked about the colors and why something is orange or blue or violet? You remember what you learned about black, the color black? This would be a good time to stop the video and write something down, or tell your teacher, why do we see something black? Well, it is when an opaque object takes in light waves, and it takes in all the light waves, okay? It absorbs all the light waves, so we see the color black. So for absorption, you could write in your notebooks when an opaque object takes in light waves. All the light waves, okay? So you can add that there, all the light waves. Now, refraction. Remember when light went through a prism and it came out on the other side as different colors, okay? Or when we did the experiment or the demonstration that we stuck a chopstick or a pencil inside a glass of water and it appeared that the pencil was bent. You remember that? Well, that is exactly what refraction is, okay? So light waves bend when it goes through a clear or transparent, same thing, transparent object. So the light waves bend when they go from one medium to another. So let's say that the light was traveling, light doesn't need anything to travel, but if light was traveling through the air and then it goes all of a sudden through a glass, a clear glass, or water, okay, then the light bends, the light waves bend. And that's what we call refraction, okay? And we have a couple of examples here that Mr. King drew. It's a flashlight, you see it right there? With a glass, or a bottle of water, and you can see that at the other end, right here, the light did not keep going in the same direction, okay? The waves were bent. And another example here is the prism. And you see how on the other side, the light waves are bent as well. The last word is reflection. That's the third way that light behaves on our planet. So reflection, and this is the easy one, because you know, you've seen your reflection, right? Mostly every day we look in the mirror, or when we look in the water, pond or river, okay? So reflection is simply when light waves bounce off objects with an even surface, like a mirror, okay? So that's the easy one to remember because you've heard that word so many times and we do it every single day, okay? Well, maybe some of us don't look in the mirror, but I love looking in the mirror. And I'm sure that you do too, right? Have you seen when people go through a mirror and they can't help but look at it? That's their reflection. That's what they're seeing. So when light is reflected, it's just bouncing off a very even surface like a mirror, all right? So those are the three ways that light behaves. I wanted to make sure that you understood that, okay? I wish I had asked Mr. King to compose a song about light absorbing and refracting and reflecting, but I didn't. But maybe at some point he can compose another song and we can share with you, okay? So here is Mr. King. He didn't do anything today, so you can just say, hello, boys and girls.
Boys and girls. I'm working on it.
All right. So have a great day, boys and girls. Remember, science is everywhere. Look for it, and I'll see you next time.